In this video today, we're going to discuss a subject very important. Safety on an electronic workbench, and in this particular video, specific subject, one of the major dangers that you'll face when working on any equipment on an electronic or electrical workbench is electrocution, which is obviously one of the major ways you can get injured, or even worse. And electrocution, like any electrical circuit, requires two contact points, one where the current flows in and one where it flows out. And since your contact point with a piece of equipment under test is accidental and can't really be avoided unless you don't work on equipment, then it generally assumed that the easiest way to prevent electrocution is to avoid the second contact point in the circuit, which the easiest way to prevent the second accidental electrical contact point is not having any other electrically conductive and grounded equipment around you that you may accidentally touch. And in that regard, your workbench should not be constructed out of an electrically conductive piece of material like steel or metal or any other electrically conductive material, because it's pretty hard to avoid touching the workbench as you're working on your piece of equipment. And a conductive workbench means that your piece of equipment is grounded when it's sitting on your workbench. And if you touch the item while having your arm rested on the workbench, then you've created a very short, quick, and lethal electrical circuit that you will regret doing very quickly. So, when constructing your workbench, at least have it constructed out of some non-conductive material. As in this workbench here, I have it constructed out of plywood. And if you do happen to have a metal frame underneath it, have some type of non-conductive material on top, or over it, or plywood or something else, to reduce the electrical conductivity that may be presented to you if you make accidental contact with the circuit, and try to avoid any other stuff around you that you may come in contact with. And look around your workbench, see if there's any other electrically conductive items that may be grounded or whatever you may come into contact with or be in constant contact with if you make accidental contact with your circuit. And in that regard, try to avoid it, propping your feet up on a metal shelf or something underneath your workbench, because having your foot on that or your feet on that and then you make contact with a active circuit, it may be the last time you do so. And also in that regard, continuing on down the line, if you have a non-conductive workbench and you make contact with something, the other most common way that the electrical circuit will be completed is via the power cord that connects that item under test to the grid power. And hence, when you make contact accidentally with the item under test, a live component on it, the circuit is continued to the mains power back to some other item that you may accidentally be in contact with, and hence the circuit is completed and you're electrocuted. So in that situation, try to get into the habit of using an isolated power supply or an isolation transformer to supply your equipment under test. Do not get into the habit of just plugging the item into normal mains power whenever you have it on the workbench and you have to open it up. Make it a general habit to use isolated power all the time so you don't have to think about it. And if it's always plugged in and you do happen to make accidental contact, because if you're planning on making contact with a live circuit, naturally you'd plug it into something isolated to prevent the electrical shock, but we don't plan on it. And because of that fact, you normally don't think of plugging it in an isolated circuit. And so if you make it a general habit of plugging it into an isolated circuit, then if you ever do happen to make contact with it, there's one less chance that the complete circuit will be made and one less chance that you'll get electrocuted. And I know the NEC has, National Electrical Code, is a bit stingy on isolated power supplies, and especially if they're installed and stuff. The only exceptions they really make is on medical equipment in hospitals and stuff. But in my own opinion, if you don't have an isolated supply that you use regularly on your workbench, and you do make contact with a live circuit, then you may end up in a medical condition. So in that regard, I kind of have a tendency to stretch the NEC rules on that. And then, for example, here on my workbench, if you see, there's two plugs here. One plug on the left, which is the non-isolated mains power, and the plug on the right, which is the fully isolated outlet that I normally use, where I make it a habit of using whenever I'm testing equipment on the workbench. And every time I plug something in, I plug it into that outlet as a default. As you see, the outlet is not making contact with the shelf above it, and it's setting on insulated standoffs. So I could have used a plastic box to mount it in, but I prefer metal, so I used insulated standoffs. And it has no other electrical connection with anything else outside of it, so you don't have to worry about plugging into something else and feeding back to it or whatever. It's a fully standalone isolated supply. You could hook one end of a 1,000-volt source to it and the other end to you, and there'd be no current to flow. And it's supplied via a 5,000 watt transformer sitting underneath. So that means the plug can supply any normal load or any normal piece of equipment under test that you may run into. That's one of the big problems I see with isolated power supplies, isolation transformers that people normally use. They're like 2, 3, 4, 500 watts, or 300 or 200 or 100 or even less. And so whenever you are testing something slightly larger, you generally don't use the isolation transformer, and something that you don't use does you no good. So if you're going to get one large enough to supply anything you're going to be testing, where you have a concern of contacting live high voltage circuits and stuff. And I know the other reason that people use isolation transformers is like testing mains, directly rectified power supplies, switching power supplies, and non-isolated chassis AC/DC vacuum tube sets. But because of that, it's also a good idea to have run on hand at all the time, so you ain't tempted to try to plug it directly into mains power, and just let the meter stand off by itself, plug it in, and tempted to reach over and just triddle that, and you make accidental contact and you get your butt zapped. So always have isolated power source handy all the time. Make you constant use of it, and try to generally avoid bypassing its use and stuff for stupid made up reasons or whatever. There might be real reasons, but you might regret it in the end. And general, when you've got your isolated power supply and your object is sitting on a wooden table, then there ain't much way the power can get back to you to make the full circuit if you make an accidental contact with something, except for the other periphery leads that you may have hooked to it, like to other alternative power supplies, test equipment, and whatever else that you may have set up around. And that's the other general reason why you don't want to have any metal contact with you, because you might have it sitting on an isolated table, isolated supply, but it's still grounded to other test equipment. And if it ain't hooked up to other test equipment, good, but if it is, you still want the physical isolation from anything around you, which is another reason for the isolated supply, because if you have said item hooked to the isolated supply and have to hook it to a non-isolated piece of test equipment, it allows you to hook on directly to hot chassis equipment without having to worry about a short being formed, which, when you're under those situations, you have to be very careful about what you touch, what you do, what you this and what you that. I'm trying to think of a way to describe this. Alright. And the other thing you want to watch out for is, like, this house here is a wood construction house, so I'm sitting on a wooden floor, which a lot of people are sitting on concrete floors, and concrete, when it's damp, is conductive. So if you have a concrete floor, take and get a rubber mat that is that you put under your chair that you're sitting on, that you're going to set your feet on. That way it insulates you from the concrete floor. So again, if it happens to be grounded via some other way and you make contact with it, then it does not complete the circuit. The general safety rule for, like, hands moving around here and everything, one bad thing it is to do is to have your hand sitting on multiple pieces of equipment at one time, because that's the quickest way to your hurt and to stop your hurt if you get across a relatively high voltage supply. So when you're working on equipment over 30-40 volts or so, try to make general habit putting one hand, your left hand, down in your lap and leave it there. Whenever the circuit is powered, reach over, plug it in, and leave this hand. I know it may be irritating to not have two hands to work on something, but just leave this one hand down here on the side. So at worst case, if you make contact with something, you'll have your wrist setting on something while touching something metallic with your hand, and you'll get shocked through that portion. But that would be the extent of it. You'll yank your hand away and cuss and complain like there's no tomorrow. But there will be a tomorrow, because of the simple fact that you did not have this hand on one piece and make contact with this. Then there would be no tomorrow, and you wouldn't be cussing anymore and complaining. So keep one hand below on your lap whenever you're working on high voltage or equipment of about 30-40 volts. Keep your equipment plugged into an isolated supply on an isolated insulated non-conductive table, and keep yourself on an insulated non-conductive flooring surface without putting your feet on anything or anything underneath the table that may be conductive. And generally in that situation there'll be very few items that you can the circuit can be completed to, therefore ending in your electrocution. At worst case, you get a mild buzz out of it and complain and stuff. And the only other objects on your workbench that will be grounded usually is like power supplies or test equipment. Now, once in a while, if you get specially built power supplies, they'll be sitting on rubber feet, and the case will be will be isolated from the main supply. But unless you generally build one yourself, you ain't gonna find something like that. On a lot of power supplies, the low voltage outputs are physically isolated from the case itself. The case is still a shock hazard, but the equipment connected to the low voltage outputs is not physically grounded to the case, so it's still a limit of the potential circuit path that may result in being electrocuted. While on other pieces of equipment like this high voltage power supply here, the case is common with the output terminals, so there is not much way to avoid that circuit path. So whenever you're using a supply like that, keep in mind that it is grounded, that any contact with anything else while making contact with the high voltage output will result in nasty surprise for you. And it's the same way with all the test equipment. That's the reason I keep test equipment sitting on a separate shelf. So unless I have a reason to connect to it, to make a test in particular, then there's physical isolation. Unless there's no reason for me to be reaching up here and touching something up here with my other hand on this unless it's physically connected to it. So a hazard avoided is a no hazard at all. And when you do connect to stuff like that, remember that it is grounded when connected to test equipment stuff, because per NEC regulations, pretty much all test equipment is grounded to mains power, and unless you have your piece of test equipment running off of individual separate isolated supplies, pretty much everything here is going to be a grounding path. So whenever you have one of these test leads plugged into said equipment and hooked to item under test, then it don't matter if you have this plugged into an isolated supply, because it is grounded via the oscilloscope, and if you make contact with this and you make contact with that, again, you're not going to have a good day. So whenever you have to hook your equipment up to grounded test equipment, keep in mind to keep your hand down where it should be, out of the way, and just use one hand, because if you're only touching this or only touching this at one time while setting on an isolated, ungrounded, non-conductive surface, then you can accidentally, now don't try it deliberately, but if you accidentally touch a live component, then you're going to be in a pretty safe situation. Well, if you don't follow those general rules, like if you have a conductive work surface, everything grounded, hooked up to a grounded supply, and you can pretty much set an unconductive work surface, there's no way you can make contact with a live circuit and not be grounded some other way. And because of that simple fact, in the final end of the story, you'll be having a bad day if you do so. So in general, when constructing your workbench, keep that in mind. Try to use materials that won't be potential contact paths for you. Try to use non-conductive materials where possible. Try to keep stuff isolated. Try to keep things positioned where you won't make a habit of setting your feet on conductive items or having your arms rest on something or whatever else, because you may leave your arm resting on something for a year or two and no problem, but you do that one time, well, I'm going to reach over and turn this one little potentiometer 5 turns here. It just takes a quick second, but it's set by a 2,000 volt source that you didn't exactly realize was that close to your wrist, and when you move around, it hits you and goes through your heart, through your elbow, resting on the metal surface that just setting to the side here, and that will be the last thing you will ever do. So whenever you're designing your workbench and stuff, whenever you're equipping it, keep in mind that the one thing that might be just a minor thing off to the side may be the final thing it gets you. In general, keep a clean, well, don't have to be physically clean, but mechanically cluttered area where there's no grounded objects that you will be making contact with on a normal, regular basis through your normal process of working on stuff. And that's about it for that this general topic here, so I'll leave it at that. Take care and be safe when you're working on stuff. Try to do something productive without being dangerous.